All right, y'all. Example 5. Jazzy, can you help me read the instruction to example 5? Good. Find the exact. So, Chris B, calculator or none?
What's that?
Thank you. Calculator or no calculator?
No calculator.
Perfect. Find the exact solution for each of these 3 equations. So, that means no calculator. We're solving for x, okay? What's the first step do you think we need to do on example A? Divide both sides by? 2. AKA, can I multiply by a half? Perfect. Okay. You can divide by 2 or multiply by a half, whatever you prefer. So now we have cosine inverse of x is what? Pi over 4. Now I want you to be very mindful. Is this an inverse function or is this a regular function? Inverse function. Do all inverse functions have restrictions? Perfect. Tell me the quadrants of restriction for cosine inverse. 1 and? Very good. Okay. So, what do you do next to find what x is?
You apply cosine on both sides?
Yeah. I wouldn't say divide, but you are going to go in and compose both sides with a regular cosine function. Okay. Because pi over 4, it's in quad 1, which fits the restriction. Can I cancel out my regular and my cosine inverse? Yep, that's why. Okay, we can only cancel when they are in the restriction of that particular strict function. Now you should know what the perfect answer is. What's cosine pi over 4? Rad 2 over 2. And that, class, is what we're looking for. Letter B, -4 times tangent inverse of x equals to pi. Tuan, what do you think you want to do first? Yep, divide both sides by -4. Okay, so now we got tangent inverse of x equals -pi over 4. Someone remind me the restriction of tangent inverse. What quads? Is it in that restriction? Yes, okay. It is totally in our restriction, so that means we can go in and compose both sides, guess what? By regular tangent. Because it is in the restriction, y'all, that means regular tangent and tangent inverse will cancel each other out. So now you just have tangent of a -pi over 4 equals to x. Do we know what that answer is?
-1.
Yes, and that's exactly what we're looking for. I'm going to hold on tight. Questions? Okay. C, last example of 7.1. What do you think we need to do? Yeah, you want to combine like terms. So what you want to do is move all the sine inverses to one side and all the constant to the other. When I say constants, pi, it's also a constant. It's just a very ugly constant, okay? So can I subtract -2 sine inverse from both sides? Yep, okay. So those are going to cancel on the right. On the left-hand side, Wes, what do you have left?
3 sine minus 1 x.
3 sine inverse of x. Very good.
Minus 2 pi.
Very good. Okay. Now we're going to go and add 2 pi to each side. Okay. So 3 times sine inverse of x equals -3 pi and a positive 2 pi. Will, what do you think?
-pi.
Very good. Next step, can you, Artemis, what do we do next?
Probably divide by 3.
Probably you're right. Okay. Sine inverse of x equals -pi over 3, y'all. Restriction for sine inverse. What quads? 1 and? Okay, 1 and 4. You got it. Is it within the restriction?
Yes.
Yes, that means you can go in and continue to solve. That means you're going to compose both sides by regular sine functions. That will allow the sine inverse and regular to cancel out. So x comes out to be sine of -pi over 3, which is what exactly?
-3, yeah.
Negative rad 3 over 2. Good job, guys. Okay. That's an egg roll for 7.1. Go ahead and grab your book and start on your tarea as I come around and stamp your homework.